Welcome to the session on fractions and decimals. The objectives for this session are to convert fractions into decimals, convert decimals into fractions, recognize terminating decimals, and recognize repeating decimals. Remember that the fraction bar also means division. So, for example, 3/4 means 3 divided by 4. And therefore, if we want to convert 3 divided by 4 to a decimal, we can multiply top and bottom by 25, which allows the denominator to become 100. So we have 75 over 100, and now we know that 75 over 100 is also 0.75. So therefore 3/4 equals 0.75. The same method works for other fractions. So for example, for a half, we multiply top and bottom by 50 and obtain 50 over 100, and this is equal to 0.5. For 1 over 4, or 1 divided by 4, we multiply top and bottom by 25 and obtain 25 over 100, and therefore 1 over 4 equals 0.25. For 3 over 5, we multiply top and bottom by 20 and we obtain 60 over 100, and so we have 3 over 5 equals 0.6. And for 7 over 8, this is a trickier example. We multiply top and bottom by 125, giving us 875 over 1000, and then allowing us to deduce that 7 over 8 equals 0.875. Now, sometimes it is easy to understand whether we need to multiply top and bottom by 50, or by 25, or multiply top and bottom by 20, or multiply top and bottom by 125. However, there are situations where it's not immediately obvious or extremely difficult. So in these scenarios, there is another method in which we can divide the numerator by the denominator, and we will look at that in future sessions. Now we ask the question, what is a terminating decimal? A terminating decimal is a decimal that comes to an end. So for example, 0.5 stops after 1 decimal place. 0.25 stops after 2 decimal places. 0.75 stops after 2 decimal places. And 0.125 stops after 3 decimal places. In other words, a terminating decimal is one which stops, it terminates. Some decimals, however, do not stop. So for example, 1 over 3 equals 1 divided by 3 equals 0.33333, and so on. We have that the 3 continues forever. And in this case, we can write 1 over 3 equals 0.3 with a dot on top to indicate that this continues indefinitely. And this type of decimal is called a repeating or a recurring decimal. Sometimes one digit repeats. So for example, 2 over 3 equals 0.66666, and so on. In this case, we can write this as 0.6 with a bar on top or with a dot on top, as we had previously. Another example is 2 over 11, which equals 0.18181818, and so on. And we can write this as 0.18 with a bar on top, like so. Let's now take a look at some examples. Can you tell us whether these decimals are terminating or repeating? 0.25, is it terminating or repeating? 0.7777 ... is it terminating or repeating? 0.125, is it terminating or repeating? And finally, 0.121212 ... terminating or repeating. Answers are coming up shortly. Now let's take a look at converting decimals to fractions. Terminating decimals are very easy to convert. So for example, 0.6 equals 6 over 10. And then we just simplify. So 6 over 10 equals 3 over 5. We've divided top and bottom by 2. And therefore we have 0.6 equals 3 over 5. Similarly, if we'd like to convert 0.75 into a fraction, we have 0.75 equals 75 over 100. Notice that the highest common factor of 75 and 100 is 25. So if we divide top and bottom by 25, we obtain 75 over 100 equals 3 over 4. And therefore, 0.75 equals 3 over 4. What about repeating decimals? How do we convert those to fractions? So for example, we know that 0.3 recurring equals 1 over 3 and 0.6 recurring equals 2 over 3. Another example, which you might consider useful, is 0.9 recurring equals 1. There are methods for converting repeating decimals to fractions, but we won't be looking at them just yet in this lesson. So let's summarize what we have learnt. In this session, we've learnt how to convert decimals to fractions, convert fractions to decimals, recognize terminating fractions, and recognize repeating decimals. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time, so you can check your answers as you go along. Pause the slideshow whenever you need to. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time, so you can check your answers as you go along. Pause the slideshow whenever you need to. This brings us to the end of this session. Do attempt the exercises in your textbook related to this topic. Thank you very much for listening.